Since its invention in the mid-20th century, the angle grinder has been creating a buzz in workshops around the world. By matching the disc-shaped attachment to the job, these versatile tools can cut, sand and polish tough materials, making them indispensable for metalwork, construction and emergency rescues. The high temperatures and friction generated by this powerful device mean the discs will gradually wear out. But the good news is they're easily replaced. And just think of all the elbow grease saved. Production starts with blocks of pure aluminium, which are melted in a furnace. The molten aluminium is then cast to create gear housings. The parts are then polished by ceramic stones in a revolving drum. A robot transfers the gear housings to a milling station and retrieves the finished parts. Inside the milling station, a computerized cutter carves threads into the center bearing seat and improves the profile of the part. The rotor for the electric motor is now constructed. An automated system first pushes cardboard end discs onto the rotor shaft. Seen here on the part on the right. The system now installs a part called the collector on one end of the rotor shaft. Made of copper and plastic, the collector will transmit power to the rotor and ensure that the grinder's disc will turn. Once again, the part on the right has had the collector installed. Spinning arms now wind copper wire into grooves at both ends of the rotor. The wire will serve as an electromagnet and maximize power output. The system now inserts covers into slots in the rotor wall, which will both insulate the rotor and stabilize the copper coil. Nozzles apply a gel resin to the copper windings to protect them from dust during the operation of the tool. Spinning devices wrap copper wire around each half of the stator, the stationary part of the motor. A robot places the two halves of the stator in a fixture and welds them together. Next, the grinder's outer casing is made from injection molded plastic. A robot transfers the casing to a platform for printing. A stamp adds silver ink to emboss the logo, making it more eye-catching. The plastic housing is then slid over the stator before a pneumatic press secures it in place. The angle grinder's on-off switch is now wired in. The gear system, which has been equipped with a drive gear and a brake, is now installed on one end of the rotor. The rotor assembly is then inserted into the stator. An automated system screws everything together to complete the angle grinder motor. Next, a nozzle fills the gearhead with grease. The spindle and safety clutch are placed over the gearhead before a mechanized system secures them with screws. The power cable and plug is then wired to the motor. The electrical wiring is enclosed in a plastic cover. And the cover is locked in place with screws, which are positioned using a metal template. This angle grinder is now ready to undergo quality control tests. This one depresses the angle grinder switch, while a computerized system analyzes the motor's performance. If it passes the test, this angle grinder is ready to go for a spin in the workshop.